I will be looking at the effect of climate change on the circulation in oceans. Before I start, I should probably point out that ocean circulation is driven by two main components. Firstly, there's wind-driven circulation. Now, this is quite shallow and only occurs in the top 100 meters of the ocean. And the second type of circulation is salinity and temperature-driven, which is called the thermohaline circulation, which I will now refer to as THC. This occurs throughout the whole depth of the ocean and on a much larger scale than wind-driven circulation. So in this presentation, I will be focusing mainly on the THC. So what is the THC? It is a global circulation system made of many regional ocean currents, including the Gulf Stream, which occurs just about here. It's extremely useful as it redistributes heat from the equator towards the poles. And if this didn't happen, the equator would be a lot warmer and the polar regions would be a lot cooler. So how does the redistribution of heat in the thermohaline circulation occur? It's driven by changes in seawater density. Now, there are two factors that affect seawater density. Firstly, temperature, and secondly, salinity. So when solar radiation at the equator heats the ocean, the water warms, and of course you know that warm water is much less dense than cold water, thus it rises, and it moves polewards. Salty water is much denser than fresh water, hence cold salt water formed from ice formation at the polar regions sinks and goes to the depths of the ocean floor. But I should point out that both tropical water and polar water are saline. It's just that this is cold, so it sinks a lot faster than tropical water, hence forming deep waters. Next. So what is the effect of climate change on the THC? How are the warmer temperatures of the Earth going to change the THC? Well, scientists fear that if global mean temperatures keep increasing, this will reduce the difference between in the temperatures between polar waters and tropical waters. In the past, polar regions have been known to warm much faster than tropical regions. Thus, the enhanced greenhouse effect would mean that the polar regions get heated a lot more than the tropics. If this happens, polar water becomes a lot less dense. Thus, the formation of deep water is much less likely to occur, as it requires a significant difference between the temperatures in the two waters. Now, how will climate change affect salinity? Well, the IPCC fourth assessment report has predicted that there will be more fresh water in the subpolar regions and increased salinity in the subtropical regions. But what's the reason behind the increase in fresh water? Firstly, rising global mean temperatures are increasing the rate at which ice sheets in areas like Greenland and Antarctica are melting. Over the last 15 years, about 265 cubic kilometers of ice has been released into the oceans on average just by the melting of the Greenland ice sheet. So this adds large amounts of fresh water into the ocean, which decreases salinity. So if this happens, it's much less likely, once again, that deep water formation will occur. And why is there greater salinity at the tropical regions? Well, tropical water salinity is increased by the solar radiation from the sun at the equator, and thus it becomes more dense because when water evaporates, the salt is expelled into the surrounding water. The density difference between the tropical waters and the polar regions thus decreases, once again, possibly slowing down the thermohaline circulation. But should we just blindly accept this hypothesis that the thermohaline circulation is going to shut down and the regions in North America and Europe are going to cool and it's going to cause an ice age? Of course not. The IPCC third assessment report notes that even in models where the THC weakens, there is still a warming over Europe. So the cooling effect of the THC slowing down is currently insufficient to overcome the warming due to the enhanced greenhouse effect. So it's unlikely that the THC will shut down over the next century. Secondly, model runs in which the THC is forced to shut down do show cooling, but mostly in the North Atlantic, not over land. So even if the THC does slow down, it's unlikely to affect areas that are densely populated. Thirdly, fresh water being released into the polar seas is currently insufficient to shut down the THC. The fresh water being released isn't enough to overcome the warming effect of global warming, so it's unlikely that, once again, it'll have a cooling effect. So ultimately, at this point in time, climate models are not sophisticated enough to include other climatic factors to give real validity to our results. So we must scrutinize our sources and question these sweeping statements in order to make a more reliable prediction.